Hello, welcome. Let's see some exercises on penicillin analogues, whether they are acid stable, acid sensitive, beta lactamase stable, beta lactamase sensitive, broad spectrum, or if they are a narrow spectrum. Let's see some of them. Let's start from ampicillin. This is the structure of ampicillin. This is the structure of ampicillin. On the structure of ampicillin, therefore, to identify one very important thing is that identifying where is the acyl side chain. This is called the acyl side chain. This is called the acyl side chain. The side chain which is found at 6th position. This is the 6th position. This is the 6th position. Therefore, identify which one is the alpha carbon. Therefore, on penicillin, this is the alpha carbon. Sorry, on ampicillin, this is the alpha carbon. Look, on the alpha carbon, there is amino group, which is electron withdrawing. Therefore, ampicillin is acid stable, orally active compound, because it has electron withdrawing group. And ampicillin, it has broad spectrum because there is hydrophilic group on the alpha carbon. And look at the structure of ampicillin here. This is the alpha carbon. Therefore, to check whether ampicillin is beta-lactam is stable or not, therefore, you have to see the alpha carbon and the 6th position. In the 6th position, there is no alkoxide group. There is no halogen group on 6th position. And the alpha carbon is not part of the ring. And on the alpha carbon, there is no bulky group that contain ortho-electron withdrawing groups like here. If this compound, if it contains ortho-electron withdrawing groups, OCH2 groups here, on the ortho position, OH groups, it will be beta-lactamase stable. But in the case of ampicillin, there is no such groups. Therefore, ampicillin is beta-lactamase sensitive, acid stable, it is with broad spectra. Next, amoxicillin, the same thing. The alpha carbon it has amino group, therefore it is acid stable, orally available. Also, there is amino group is hydrophilic group, therefore the spectrum is broad. And there is no substitution at 6th position, either halogen or alkoxy group. Therefore, also here there is no bulky group on the alpha carbon, and alpha carbon is not the part of the ring. Therefore, amoxicillin is not beta-lactamase stable. It is sensitive to beta-lactamase. Propacillin, the third compound. Let's go to the alpha carbon here. This is alpha carbon. On the alpha carbon, there is oxygen. Oxygen is electron withdrawing group. Therefore, propacillin is acid stable, orally active. But oxygen is not hydrophilic. There is no other hydrophilic on the alpha carbon that is directly connected. Therefore, propacillin is not broad. Its activity is not broad. It is narrow. And propacillin, beta-lactamase. Here there is no substitution at 6th position, meaning that no substitution means there is no alkoxide and there is no halogen group on the 6th position. And the alpha carbon, it is not the part of the cycle. It is not the part of cycle. Therefore, propacillin is not beta-lactamase stable. It is beta-lactamase sensitive. But if I make this molecule like this, if I make a ring here like this, a ring here, it will be beta-lactamase stable like this. If I make a ring that oxygen containing side chain with alkyl group making like this. If I make this one like this, it will be heterocycle or cyclic. Alpha carbon will be part of the cycle. It will be beta-lactamase is stable. But propacillin is not. Beta-lactamase is stable. Next, nafcillin. This compound. This is the alpha carbon. This is the alpha carbon. The alpha carbon is the part of the ring. Therefore, if the alpha carbon is a part of the ring, that is bulky. Therefore, it is beta-lactamase stable. And alpha carbon, it doesn't contain electron withdrawn group here. Therefore, it is susceptible, sensitive, labile for acids. Therefore, it is not given orally. And there is no hydrophilic group here on the alpha carbon. Therefore, nafcillin is not broad. Let's come to the thymosilene. On thymosilene, look, the alpha carbon is this one. On the alpha carbon, there is a carboxylic group and there is a heterocyclic group on the alpha carbon. Therefore, alpha carbon contains carboxylic group, but there is no electron withdrawn group that is directly connected with alpha carbon. Therefore, thymosilene is acid labile, acid sensitive. It is not given orally because of the lack of electron withdrawn group on the alpha carbon. But thymosilene has highly hydrophilic group, that is carboxylic group. Therefore, it has broad spectrum. And alpha carbon is not the part of the heterocycle or the ring. Alpha carbon is not the part of the ring, but alpha carbon contains heterocycle. Therefore, if it contains heterocycle, it will not be acid stable. But if the heterocycle is the part of the ring, it will be acid stable because of the electron withdrawn nature of the element which is found on the alpha carbon. And the beta-lactamase activity here, this compound, the alpha carbon is not the part of the ring. There is no bulky group on the alpha carbon, but on the 6th position there is methoxy group, which is very important for beta-lactamase stability. Therefore, it is beta-lactamase stable compound. Therefore, thymosilene is beta-lactamase stable, broad spectrum, acid sensitive, not given orally. Methicillin. This is alpha carbon. Alpha carbon is part of the ring. Therefore, it is beta-lactamase stable. There is no electron withdrawn group on the alpha carbon that's directly connected with on the alpha carbon. Therefore, it is labile for acids, hydrolysis. Therefore, it is not given orally, acid sensitive. There is no hydrophilic group on the alpha carbon that is directly connected. Therefore, it is not broad. The others, azilocillin and the piperacillin. These are some of very important compounds also with extended spectra. They are broad spectra. Therefore, here in the structure of azilocillin, here we have on the alpha carbon, there is nitrogen. Nitrogen, carbon, oxygen, nitrogen. Therefore, if you have such groups on the alpha carbon, meaning that NHC double bond N or NHC double bond NH, these groups, if you have these groups, NH C double bond or N or NH, the electronegativity of the two group will be cancelled because of the same element nitrogen. They will not be electron withdrawn. Therefore, azilocillin, as we saw earlier here, in this case, we say that in the group, if we have these such groups, NHCOH, N series, aminopenicillins, the electron withdrawing effect of this will be 0. Therefore, the inductive effect is 0. Therefore, here such groups, they will not act like electron withdrawing. Therefore, the compounds will be acid labile. They will not be given orally. And we have in this structure, we have NHC double bond or N series. Compounds containing NHC double bond N, they are called aminopenicillins. They are with extended spectrum. This will increase spectrum or activity of the drugs. Therefore, they have extended spectrum of activity because the hydrophilicity of this group is the highest. They are highly active on gram-negative bacteria. Similarly, piperacillin, it has similar NHC double bond NH group. Therefore, piperacillin, azilocillin, they are acid sensitive because of the presence of NHC double bond N. They are highly hydrophilic and they have extended spectrum. And when we come to the beta-lactamase stability, here on the alpha carbon we have these groups. They are not shielding group. They are sterically weak groups. Therefore, here also the alpha carbon contains the aromatic ring. This aromatic group is not as much sterically hinders the enzyme that is responsible for cleavage of the beta-lactam ring. Therefore, also there is no methoxy or halogen group on the 6th position. Also here. Therefore, they are beta-lactamase sensitive, acid sensitive, but with broad spectrum of activities. But in this structure, if I introduce here alkoxy group or electron withdrawal group, ortho or diortho, this will increase beta-lactamase stability. Therefore, the compound will be beta-lactamase stable. If I introduce OCH3 groups or any electron withdrawal groups. Therefore, these compounds, they are beta-lactamase sensitive compounds. Let's see another compounds like cloxacillin, dicloxacillin, flucloxacillin. Here the alpha carbon is this carbon. Here we have the alpha carbon. The alpha carbon is the part of the heterocycle. Therefore, compounds that contain heterocycle on the alpha carbon, meaning that if the alpha carbon is the part of the heterocycle, the compounds will be acid stable and they can be given orally because they can shield, they can protect, they can prevent degradation of the compound by acidic hydrolysis. They are beta-lactamase stable, they are acid stables. Beta-lactamase stable because the alpha carbon is the part of the ring, and they are acid stable because the alpha carbon is the part of the heterocycle. And they have narrow spectrum because there is no hydrophilic group here on the alpha carbon. These are some examples of compounds that are mentioned here. Also, let's see some important compounds here. We have generic names and chemical names. This is the alpha carbon. The alpha carbon here. Here we have Ra group. For example, these are Ra groups for these compounds. This is the Ra groups for these compounds. Let's see whether they are acid stable, beta-lactamase stable, or with broad spectrum. Look, here the alpha carbon is this carbon. The alpha carbon is this carbon. Starting from that carbon, for this molecule, this is alpha carbon. For this compound, this is alpha carbon. This is alpha carbon. For this compound, this is alpha carbon. For this compound, this is alpha carbon. This one. For this compound, this is alpha carbon. 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 For 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 this, alpha carbon, alpha carbon, alpha carbon. Let's see whether these compounds, they are acid stable or acid sensitive, beta-lactamase sensitive or beta-lactamase stable with broad spectrum or narrow spectrum. Let's see the first one, which is called penicillin G. On penicillin G, There is no electron withdrawn group on the alpha carbon. Therefore, it is acid labile, acid is sensitive, not given orally. There is no hydrophilic group on the alpha carbon. Therefore, it is with narrow spectrum. There is no alkoxy or halogen group on the 6th position. Therefore, it is beta lactamase sensitive. Also, the alpha carbon is not the part of the ring. Also, on the alpha carbon, there is aromatic group. On the aromatic group, there is no electron withdrawn group on the ortho position. Therefore, this compound is beta lactamase sensitive, acid sensitive, narrow spectra. The second compound, this compound, penicillin V. This is alpha carbon. On the alpha carbon, there is electron withdrawn group. Therefore, it is acid stable, orally active compound. Alpha carbon is this one. On the alpha carbon, there is no hydrophilic group. It is oxygen. Oxygen is not hydrophilic. It is electronegative. Therefore, it is not broad. It is not broad. And the alpha carbon is not the part of the cycle. The part of the cycle. Therefore, it is beta lactamase sensitive. Therefore, pen V is beta lactamase sensitive, narrow spectrum, and acid stable, orally available. Methicillin, alpha carbon here. The alpha carbon is the part of the cycle. Therefore, it is beta lactamase stable. On the alpha carbon, there is no electron withdrawn group. There is no electron withdrawn group. This O group is not on the alpha carbon. These oxygens, they are not on the alpha carbon. They are on the beta position. Therefore, on the alpha carbon, there is no electron withdrawn group. On the alpha carbon, there is no hydrophilic group. Therefore, methicillin is beta lactamase, is stable with narrow spectrum. It is acid sensitive compound. Similarly, this compound, naficillin. This is alpha carbon. Alpha carbon is the part of the ring. It has good shielding group. The alpha carbon is the part of the ring. Therefore, it is beta lactamase is stable. There is no electron withdrawn group. There is no hydrophilic group. Therefore, it is not acid stable, not given orally. It is not broad. Also, go to the oxacillin, this structure. In this structure, alpha carbon is this one. Alpha carbon is the part of the ring, heterocyclic ring. Therefore, it is beta lactamase stable. Also, it is acid stable because the alpha carbon is the part of heterocycle. It is acid stable, beta lactamase stable. On the alpha carbon, there is no hydrophilic group. Therefore, it is narrow spectra. Oxacillin, similarly with cloxacillin, similar with oxacillin, the same structure. Therefore, it is beta lactamase stable, acid stable with narrow spectra. Also, this compound, the same. This is alpha carbon. Alpha carbon is the part of the heterocycle. Therefore, it is acid stable, beta lactamase stable, but with narrow spectra. This compound, ampicillin, look. Here we have on the alpha carbon, there is NH2 group. Therefore, it is broad spectrum. There is hydrophilic group. Also, on the alpha carbon, NH2 will act as electron withdrawn group. Therefore, it is acid stable oral compound. Also, on the alpha carbon is not the part of the ring. Therefore, it is beta lactamase sensitive. No electron withdrawn group on the ortho position of the alpha bulky substitution. Therefore, it is beta lactamase sensitive, acid stable, orally active, and with broad spectrum. The same amoxicillin. Look, alpha carbon is this one. There is an amino group. There is an amino group. Therefore, it is hydrophilic, electron withdrawn. It is acid stable, orally active, with broad spectrum. And alpha carbon is not the part of the ring, and there is no alkoxy or halogen in the parent structure for this compound. Therefore, it is beta lactamase sensitive or labile compound. Cycloacylin, here this is alpha carbon, the ring carbon. Alpha carbon is the part of the ring, therefore it is beta lactamase stable, resistant, beta lactamase resistant because alpha carbon is a part of the ring. On the alpha carbon there is amino group, hydrophilic group, electron withdrawing group. Therefore it is beta lactamase stable, resistant, acid resistant, orally active compound, and it is broad spectrum. Then carpenicillin. This is alpha carbon. On the alpha carbon there is carboxylic group. This carboxylic group is not electron withdrawing group, but it is hydrophilic group. Therefore, on the alpha carbon we have carboxylic but not electron withdrawing group. Therefore, it is acid sensitive compound, not given orally, but it is broad spectra. It has broad spectra. And beta lactamase activity, there is no bulky group on the there is no bulky group on the alpha carbon, but also in the bulky group on the aromatic group there is no electron withdrawing group on the ortho position. If I make here OCH3 group, it will be beta lactamase stable, but here there is no electron withdrawing group that are attached on the aromatic ring which is found on the alpha carbon. Therefore, also here on the sixth position there is no alkoxy or halogen group. Therefore, this compound is beta lactamase sensitive, acid sensitive, not orally given, and broad spectrum. The next compound, this compound, this is alpha carbon. On the alpha carbon there is no electron withdrawing group, therefore it is acid sensitive, but there is hydrophilic group. It is with broad spectrum. Also, alpha carbon is not the part of the ring, beta lactamase sensitive. This compound, it has alpha carbon. On the alpha carbon we have NHC double bond N series. Such compounds, they have very lesser, weaker electron withdrawing effect. Therefore, they will not act like electron withdrawing. Therefore, they are acid sensitive. They are not given orally. And there is highly hydrophilic group on the alpha carbon. They are with beta spectrum. They are considered as with extended spectrum of activity because of the hydrophilicity of this group. And the alpha carbon is not the part of the ring. No, not the part of the ring. Therefore, and alpha carbon on the sixth position there is no halogen and alkoxide groups. Therefore, it is beta lactamase sensitive compound. Beta lactamase sensitive compound. Therefore, this compound is beta lactamase sensitive, acid sensitive, but with extended spectrum. The same thing for this compound. The same thing for this compound. This is the first exercise. Also, we will see the second exercise in the next slides. Thank you so much.